Okay, let's dive right into this. Welcome to today's Explainer Masterclass. I want you to imagine, just for a second, that you're standing right at the edge of an active archaeological dig site. You've got your brush, you've got your trowel, and you're staring at a patch of dirt. Now, to the untrained eye, it's just earth, nothing special. But to an absolute expert, it's a treasure trove waiting to be unearthed, layer by meticulous layer. And honestly, that is exactly how you need to approach your Cambridge physics examinations, specifically Paper 2, Syllabus Code 9702. Today, we're going to act like we're on the site together. We're cracking open a real past paper question on quantum physics. And we aren't just going to scrape the surface. We're going to dig deep, uncover the hidden clues in the question, and layer by layer, reveal that perfect maximum mark answer. So why exactly are we focusing our digs specifically on quantum physics and the photon momentum equation P equals E over C? Well, it all comes down to this number right here, 15. The quantum physics photon momentum topic accounts for approximately 15% of your total marks in Paper 2. That is a massive chunk of your final grade sitting in just one conceptual area. If you can truly master this, you aren't just passing the paper, you are building an impenetrable fortress around your A-star. Let's look at exactly how we're going to secure that 15% today. Here is the map for our dig today. First, the challenge, where we'll look at the common exam pitfalls. Second, unearthing core concepts. Third, the method mark strategy. Fourth, mastering critical analysis. And finally, avoiding examiner traps. All right, let's kick things off with Section 1, the challenge, common exam pitfalls. You know, the Cambridge exam hall is an incredibly high-stakes environment. The clock is ticking down, the pressure is immense, and when students open that booklet and see a complex quantum physics question involving P equals E over C, sheer panic often sets in. And that panic? It leads directly to some incredibly common pitfalls. To understand exactly what the examiner wants to see, we first need to understand what they absolutely hate seeing on the page. Let me introduce you to two typical candidates. We'll call them Alex and Sam. When asked to evaluate the momentum of a photon related to its wavelength, Alex completely overloads the page. Alex just throws down every single raw physics fact about the photoelectric effect and wave-particle duality they can possibly remember. It's a massive, chaotic data dump with zero actual analysis of the specific question asked. Naturally, the examiner's red pen just slashes right through it. Now, on the other side, we have Sam. Sam rushes. Sam sees the word momentum, furiously plugs a few numbers into a calculator without ever defining the formula, and completely misses the command word requirement. The question asked to deduce and explain, not just calculate. Both of these approaches completely miss the mark. They miss the crucial analysis, and they miss the command words. We absolutely cannot afford to be Alex or Sam, and that brings us to Section 2, Unearthing Core Concepts, Theoretical Architecture. Look, physics isn't just about blindingly memorizing equations. It's about mastering precise definitions and establishing clear, logical, causal relationships. Let's look directly at our core tool for today, photon momentum, where P equals E divided by C. This definition is vital. The momentum of a photon is directly proportional to its energy and inversely proportional to the speed of light in a vacuum. But here is the real insider secret to unlocking the absolute highest marks. Examiners actively, aggressively reward candidates who make cross-topic connections. If you can logically link P equals E over C back to the de Broglie wavelength equation or connect it to the discrete energy levels in an emission spectrum, you are demonstrating a holistic mastery of Physics 9702 that instantly pushes you into the elite top tier of candidates. What's really fascinating here is how perfectly this maps directly to the examiner's actual expectations. The syllabus targets 3 specific cognitive domains. First up, knowledge and understanding. Do you actually know the formula and the foundational definitions? Second, application. Can you successfully plug the right data into the right places? But the third domain, that is where the A-star is definitively won or lost. Critical analysis. Can you evaluate the evidence? Can you clearly explain the why behind the numbers? If you are only operating in that first domain of basic knowledge, you are severely capping your own grade. So, how do we fix that? Let's move to Section 3, the method mark strategy, procedural execution. You know, in Cambridge physics, that final answer scribbled at the bottom of the page, it's often only worth a single solitary mark. The structured process itself is where the bulk of that 15% we're chasing today actually lies. You are heavily awarded for showing a systematic, logical sequence. Top students use a very specific underlying structure to construct their physics answers logically, especially for those tricky descriptive or qualitative questions. It's called the Peel framework, Step 1. Point. Clearly state your primary physics principle. Step 2. Evidence. Provide the hard data from the question or state the specific equation, like P equals E over C. Step 3. Explanation. Detail the causal relationship. For instance, as energy increases, what exactly happens to momentum? Step 4. Link. Connect your thorough explanation directly back to the specific command word used in the prompt. Now, for the quantitative, math-heavy questions, you absolutely need this standardized 5-step sequence for systematic processing. Step 1. Deconstruct the question to isolate the command words. Step 2. Extract all given data and rigorously write it out with the correct units. Step 3. Select your analytical framework by writing down your formula. Step 4. Execute the calculation with incredibly clear, step-by-step working out, absolutely no mental math allowed. And Step 5. Present the final answer with correct terminology, proper formatting, and the appropriate significant figures. This precise workflow is how you guarantee every single method mark. Okay, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, it is time for a 30-second challenge. Look at the two answers in front of you and mentally decide which one perfectly executes that Peel framework we just broke down. I'm going to give you a few seconds to spot the flawless application. Time's up. If you picked the answer that explicitly stated the relationship, cited the formula as concrete evidence, explained the proportionality, and cleanly linked it back to the scenario, you nailed it. That right there is the success blueprint. It's all about transforming chaotic, panicked data dumps into highly structured, green checkmark-worthy responses. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Awesome. Let's jump straight into Section 4, Mastering Critical Analysis Interactive Workshop. Look, you cannot learn physics passively. You just can't. So I need you to actively engage with evaluating the evidence and extracting the data with me right now. We are going to train your eyes to see exactly what the examiner sees. Here's Challenge 1, the data scan. Take a look at this complex physics table mapping wavelength, photon energy, and momentum. The timer in your head should be ticking down from 60 seconds. Scan the data. What is the absolutely core trend you need to extract here? Well, if you look closely, you'll see the inverse relationship beautifully mapped out. Because E equals hc over lambda, a high wavelength results in a very low photon energy. And because P equals E over C, that low energy directly translates to a low momentum. Conversely, a low wavelength means high energy and high momentum. Extracting this core trend instantly sets up your entire analytical framework. Okay, let's step it up to Challenge 2, Find the Flaw. Read the sample paragraph we're evaluating. The student has correctly identified the trend, they plugged in the numbers perfectly, but they are still missing out on the top band of marks. What is missing from this comparative analysis? Why on earth did the examiner ruthlessly withhold the final points? So, the critical flaw? The student totally failed to explicitly evaluate the evidence. Top candidates don't just blandly state facts, they strategically use comparative connectives. They say things like, whereas the first photon exhibits high momentum due to its high frequency, the second photon conversely shows a diminished momentum. It is all about identifying similarities and differences. Furthermore, the absolute best candidates will actively evaluate the limitations of the evidence, perhaps mentioning the assumptions made about acting in a perfect vacuum. That high level of critical analysis is your golden ticket to the A-star. Now we reach Section 5, Avoiding Examiner Traps, the final evaluation. Listen up, because this is arguably the most crucial part of our dig today. We've gone directly into the principal examiner reports, the actual official documents written by the people marking your papers to find the hidden booby traps that catch thousands of students off guard every single year. These are the top 3 mistakes highlighted exactly as they appear in the reports. Mistake number 1. Answers are way too vague. When discussing P equals E over C, just saying it gets bigger isn't going to cut it. You must say momentum increases proportionally. Mistake 2, forgetting format and presentation conventions. Leaving off units or not showing your working out clearly will literally bleed your marks dry. And mistake 3, answers are not specific to the given context. If the question is about an X-ray photon, please don't give a generic answer about visible light. Meticulously tie your physics back to the exact scenario provided. I really want you to hear this directly from the principal examiner. Quote, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Listen to me very clearly on this. Do not ever use a term like photon momentum or work function or threshold frequency in an extended response without briefly defining it first. This one simple act proves to the examiner that you possess the core foundational knowledge, instantly elevating the perceived quality of your entire answer. Now, to help you remember this procedural framework under the intense stress of the exam room, I've put together a little memory hack for you. Just remember the acronym PACE, P-A-C-E. Present your core equations clearly. Annotate your working out step by step. Contextualize your answer to the specific question being asked. Execute with the absolute correct units and terminology. If you can just keep your pace, you will navigate the hardest quantum physics questions with total ease. All right, let's bring it all together and recap the complete physics answering system. These are the 3 golden rules that guarantee top marks on paper 2. First, command word decoding. You have to know exactly what evaluate, deduce, or calculate actually demands from you. Second, Peel framework application. Structure your qualitative answers so your logic is simply undeniable. Third, time management matrix. Do not spend 10 minutes sweating over a 2-mark calculation. Allocate your time strictly proportionally to the marks available. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That is the literal difference between a B and an A star. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. I'm going to leave you with one final provocative thought today. We just dug incredibly deep to uncover the strategy for the 15% of marks locked away in photon momentum. But if P equals E over C unlocks 15% of your exam, what hidden clues are you completely missing in the remaining 85%? Keep digging, keep analyzing, and I'll see you in the next Explainer Masterclass.